We're live. I had to struggle really to get on live. I don't know what was going on with YouTube. They just did not want me to do the live feed. But if you have joined us, welcome. And please take a look at the video that I just, just posted this morning on the 2.2 liter. And you guys can see kind of tales of woe, although getting the thing like up and running was awesome. I mean, I get excited every time we start a motor up and actually hear it run and do the thing that it's supposed to do out of its environment. I mean, every day you go out and get in your car or truck or whatever, and you start it up. And especially if it's a daily driver, we just take that for granted that it just, hey, look, it all just works. But it doesn't always do that. And getting it to do that with everything hooked up the way that the factory had it, or maybe you've gone to great effort to make all that stuff work. We have to go to that kind of effort to get stuff to work on the engine dyno, and this 2.2 was no exception. James Reeves from Reeves Racing helped us out with a bell housing adapter, which just worked flawlessly as you saw the video. As soon as I applied it to the right bell housing to the small block Dodge instead of the LS or small block Chevy, which are the same, and big block Chevy. I mean, I was putting it on there, wiggling around, going, why isn't this fitting? Why do I all of a sudden not know anything about cars anymore? There's no way that this goes with this thing. It just doesn't work. I can't get very many of these holes to line up. And when I do, the thing's all cattywampus and askew to one side or the other. I'm like, this can't be right. And after I called him, he's like, oh yeah, no, it's not right. You have to put the right bell housing on there, and then it works perfect, which it did. The thing bolted right on. It worked great, and that allowed us to put it on. Also, the big shout out to the guys at the car farm, Ben and Brian, for sending out the flywheel that I needed and the flywheel bolts. And then I just had to re-drill just basically make the holes in our drive plate a little bit longer, because as you might imagine, this is the first time that this has ever run. So there's no dedicated drive plate for 2.2 liter turbo motors. So now there is. I had to make that. Motor mounts usually for setting something up like this on the engine, I know, very easy. You just have L brackets and bolt it to something that's on the block, usually an accessory, a hole or something. And then if you have to space it out, depending on what the block, bows in relative to the oil pan, you just use spacers or whatever. That stuff is all fairly easy. Then on the exhaust, because this is a sidewinder motor, basically, it's a front wheel drive, the exhaust wants to aim out toward the wall and toward the toolbox. So you just have to have a bend. And I could have made something, but luckily in the things of stuff that we already have that we made, what the tag said on it was a tune port small block Chevy manifold that we had used for something. And that just bolted right onto it. It was kind of nice. It even had the cone gasket and the flange. The spacing on the flange was right. So that was, sometimes it doesn't always go right, but sometimes you just walk up there and you get something and it goes right. Now I would have had no trouble putting a bend and welding the thing that we needed. In fact, I kind of want to, when we run the turbo thing, I want to run the exhaust. I want to run some sort of exhaust and muffler and stuff, so that we can show what that does. And even if we only did that for a couple of tests, we could show the difference between what that is and then what either a free-flowing exhaust, like a 3-inch with a muffler on it, or a no exhaust at all. I kind of want to run, when we get to where we're turning the boost up and doing that stuff, I kind of want to have a free-flowing exhaust on there, but I might do a 3-inch exhaust with a 3-inch muffler, because we have those. And so making that will be fairly easy. At least a 2.5, because I have a whole bunch of that from when I did the video on the remote turbo stuff. So that will be good. Also, if you take a look at the video, you'll notice that I use a stock exhaust manifold from an NA 2.2 liter, because we ran this motor NA and I wanted to start out that way. And as it turned out, and this is one of the reasons that we do it. If we're going to find a problem, let's find a problem without boost. Let's find it NA. Perfect example, 55 degrees of total timing. And I can't believe the thing didn't get hurt, but it wants to run and did well. The thing I want to talk about today is, if you guys have seen this, let me know, what is the weird power curve thing? A lot of guys want to point to valve float, but I'll tell you what happens every time we've experienced valve float on any motor, whether it's a Ford or Chevy or Dodge or Honda or whatever it is. Whenever we get valve float, what we have is some sort of nice smooth curve, and then it'll just drop off. I call that a geometric change in the power curve, and it just gets unhappy and it starts, and you can hear it on the dyno too. It's when you run into valve float, if you have an air hat on it, you can definitely see it because the airflow is going up and up and up, and then it goes down. And when it does that, bad things happen. You can hear it because the motor becomes unhappy, and then you can also see it in the power curve. This is not what we're seeing. We're seeing a nice smooth curve, and then whoa, it gets on this little, I call it a little VTEC hump. So I'm not sure what's going on. Jeff Smith was there, and he came up with an interesting observation. Obviously, he hasn't tested any. I say that he doesn't have any 2.2 experience, but he does. He actually drag raced them. He actually drag raced naturally aspirated ones in NHRA way back. He had a, I think it's a Turismo that he raced, and he raced against the guys from Motor Trend, I think. And I think that the story they told me is that they cheated up their motor just in an effort to beat him. He was running his; it was all stock, so it was a good story. But what he said, and he hasn't ever run any of them on the engine dyno, but he said, well, maybe what we're looking at is the curve wants to be where that is. And because there's so much timing in it, that the rest of the curve is bad. I thought, oh, see, and that's why we have different eyes on these things. If you have different eyes and different perspectives, usually you yourself will look at it and go, okay, because of my experience and history and all this stuff, and I'll tend to go off down this direction. And you'll miss a lot of other things. And then somebody else, and most guys are like, well, this guy knows more than you. No, they are, again, people know different things. And so another set of eyes will look at it and go, hey, here's also something else that we should think about. And that is nothing but good. And that's one of the reasons I really like testing at Westech. There's a lot of sharp guys there, and there's more than one guy looking at it, and they're coming at it from different perspectives. And different knowledge bases and stuff. And they go, oh, well, what about this? Or what about this? Or what about this? Especially, the guys that are running stuff on the dyno all the time, every day, they see stuff, things go wrong. And then when you go through have all this experience and things go wrong, you put all those, oh, well, when this went wrong, this is what it was list. And then you go back and reference that with your brain and go, oh, well, when this happened, this happened. So this is an interesting thing. I'm not quite sure. I don't know if it's timing related. If it's valve spring related, I don't think that that's the case, but it might be. The other thing that's possible is this is a very, very low power motor relative to what that dyno normally sees. I tried to and had to do a lot of adjustment on the servo to get this thing in a happy range to where it wanted to run, because it has to supply enough water and not too much water and to the absorber. And so we get it with the servo in the range where it doesn't go lower than, like, let's say mid-teens, and it can't go higher than 100% load. So we have to adjust that so that it's in its happy sweep spot, which is why we can't run a motor from, I know all of you guys want to see it off idle to 9,000 RPM or whatever. The dyno just won't do that. And it makes it even more difficult if it's a combination that is not making very much torque and power. And this one is like that. Like, it'd be a lot easier to run a wider spread on a small block that's a 400 horsepower small block that makes 400 foot-pounds down low. And the length of the RPM range that we could run for something like that would probably be wider than what we're dealing with now. That situation tends to get better once we add the turbo. We went through this with the B16 Honda as well. When it was running NA, it's just a little more difficult to get a broad RPM range, a test RPM range. Once we added the turbo, it was like, oh, well, now we're making power and now everything's okay. It's making torque and it's making horsepower. So when it has both of those, the dyno gets much happier in that sort of range. They are putting a power mark on there as one of the dynos before too long. But it's so nice. It looks like the model home equivalent of a dyno, because the owner of Westech has tricked this thing out. It is amazing. I'm sure it's the nicest one in the country, because he spends a lot of time and effort on making this thing really nice. I'm sure I'm not even going to be allowed on it, which will be fine too. But I can't wait to run the turbo stuff. But mostly now I can't wait to get this thing running. I mean, it did respond to timing, because as I said in the video, I tried adjusting the distributor when we were going through it, and this thing always wanted to run really, really high timing, I'm like, okay, well, let's just go out and load this thing where it goes into this, I'm going to run all the timing thing, and let's just turn the distributor and let's make the timing be what we want it. We know that it's going to ruin the timing down low, and we tried to adjust that, and we couldn't adjust it enough because now we don't have enough reference angle to play with. So you can't get a good combination of both, but let's just turn it and make it be 25 degrees while it's up there and 30 degrees. And we could do that. And when we did that, I showed that in the video. It did that. And there is a change in power between 24 degrees and 30 degrees, as we showed. And 30 is kind of where I think this thing is going to want to be. But we always start out low, which we did. And the interesting thing is when we were running this thing, when we initially set it up, we go up and we set the reference angle. We move the distributor until we have the number that we're asking for in the computer, and we verify that those two are synced. And then we change the number in the computer. And we verify it with a timing light that it changed. Okay, we set it at 25. It's 25 here. Okay, that's all working good. Now let's go in and make it 30. And then we look at a timing light. Yes, it's at 30. And let's go down. Let's go to 15. Yes, it's at 15. And once we validate that it's doing what it's supposed to do, which is the same procedure that we go through for all of these, and we went through it with this, and it worked perfectly at idle. But no matter where we set it down low, it would only do, it only wanted to do that. So we think that it's the size of the teeth in the trigger wheel in the distributor, combined with the fact that it's such a small diameter, that we think that the signal gets messed up. It's not a distance of the sensor away from that. In fact, we tried another sensor. We're using a 24x crank sensor from the LS, which is if you look at the thumbnail photo, that's the modification that I did to that distributor. So I basically slotted the side of the distributor and then made this L angle mount for the crank sensor. And you can see I had to use a spacer just so that we could keep we wanted the mounting bracket for the sensor to be square to be flush and so that the sensor was flush with the mounting plate, so that it was straight and not cocked at an angle. So one side of the sensor wasn't closer than the other. So a little bit of work went into that, but it's not, it's not hard. It's just it's just two holes and then a couple of holes. We use the existing screws on the distributor to mount the plate. And that all worked out good. And so that allowed us to use the LS harness, and we're using a Holley HP. And so normally when everything's working right, we can just dial the timing in the air fuel. And it would take changes in air fuel. We used 80-pound injectors, hoping that, hey, look, once we go through some NA testing and we start adding boost, we're going to need more fuel. And we know that we're going to run E85 on this thing at some point. And so we want to make sure that we have enough fuel flow for that. And all of that stuff was actually working fairly well, with the exception of this weird power curve and then not being able to, accurately control the timing. But I was very excited that it ran. And then using the stock exhaust manifold, I think I swallowed a bug. Using the stock exhaust manifold, I can run an exhaust section under the motor and over the other side. So if we want to put the turbo on the other side, I can. I can test that stock exhaust manifold versus the standard turbo exhaust manifold, which is basically a big common log. And so once we'll get this dialed in. I'm sure it's not a big deal. Eric and Ish and I spent a lot of time trying to get it to work. It's probably a hard part problem, and it's certainly not a tuning or a software problem. But we'll get that, and then once we do, we can start running boost. The motor seems to be happy. It has good oil pressure. I was excited when I ran the oil pump. Man, when I ran the oil pump, it worked good. I mean, I like pre-lubing the motor before we started, especially on a fresh rebuild. One thing I didn't do on this, because we were struggling with the timing, is I didn't run it through break-in cycles. So all of the stuff that we did, including full throttle loads, hopefully that broke it in. Seems to be okay. It's more of a razor blade rebuild than anything anyway, so it should be fine. It does have ring gap in it so that we can turn the boost up on it, although it has the small head bolts on it, and we'll see what happens with those. I tend to think that we can run, a good amount of boost, a reasonable amount of boost for this thing. And the goal of it isn't to, and it's a hard thing for a lot of guys to understand. They're like, oh, this is a cool like build up. I'm like, well, it's not really build up. If it was a build up, it would be different. And the build up will come next, which will be the 2.5. And that will be a little bit more dedicated of a thing. Although we'll start out at low boost levels for these kinds of reasons and make sure everything's right. And then we can go up and try different camshafts and stuff on the 2.5. The 2.5 will have a forged piston in it. It will have a stock rod in it and a stock crank, but it will allow us to lean out a little more. It will also have head studs and an MLS head gasket. And then we might try, I might go right to a ported head on that. We'll just see how the ported heads do. I'm going to do a video on all of the porting data and see how we can see how they compare and see if we think that those are indeed going to help power. Most of the gains from the porting seems to be in the higher lift ranges. And so we have to have camshafts that will be able to take advantage of it. If they're comparable all the way up to 400 lift, let's say, and the camshaft is a 410 or 420 lift camshaft, maybe you don't get big gains from that. We'll have to see, but it'll be interesting. Let's see. So we got to have a poll. That'll be good. So the morning motivation, it is around 10 o'clock. So it's still morning here. Get your projects done. So the poll for today will be, will you spend the weekend getting a project done? So are you going to be working on a project this weekend? Basically, that's what the question is. The poll is a roundabout way of asking that. But I'm excited about this 2.2. I've had my list of things. In fact, I have it here. I have my list of 20 things that I want to test and have been agonizing over that for a really long time. It's been more than a year now since I think I made that list, because I made that back when I was, and maybe even before I bought the GLHS or the GLH, and the S is in air quotes, because I know it's going to make all the Shelby guys mad, but I'm going to call it what I call it. So I made a list of all the things I want to do. And the reason that I do that ahead of time is it helps me with organizing the things that I need to get all this done. Okay, I want to do this, and we want to run it because we want to run it non-intercooled. We want to run it the way that it was as an 84 or an 85 motor, run it non-intercooled. It's a draw through, which is interesting. And we want to test that. And I want to test vacuum between the throttle body and the turbo and see what we have going on there. Test bigger throttle bodies. We obviously are going to do an intercooler upgrade. We'll test. We don't really need to test different injector sizes, because the injector size really, if you go looking for power there, based on spray pattern or atomization or those kinds of things, it's going to take a real concerted effort for you to find that. It's like, I liken that to indexing plugs and stuff. You might be able to find something there, but you probably have to go through more than a few sets of injectors to really find anything. And you'd only find that, the only way that you would find that is if you had something that was ultra repeatable and you're looking at, small gains. So we would just have enough injector to supply all the fuel that we need for all of our testing. But intercoolers are a good idea. Like I said, the bigger throttle body, the different intake manifolds, different camshafts, changing the cam timing with existing camshafts, heads, ported heads, different slider versus roller, the swirl head versus a stock head. There's lots of good stuff there. And I think it will help guys understand in this 2.2 community, just like it does in the Honda or LS or small block Ford or Chevy. When we run these mods and change it NA and then apply it to a turbo, they'll go, oh, it does that over here on the turbo side because it did that over here on the NA side. And that's the thing I'm trying to get people to understand with camshafts too, is you just need to look at the NA power curve, and that will tell you how things work. And I know that there's people out there that have a real hard time. They have dug their heels in and they will not separate that. Oh no, turbo cam. It's gotta be that. I'm like, well, no, it really doesn't. But I digress. So how's our poll doing? 71% are saying that they will. They are going to be working on it. That's good. I like to see that. Not everybody can work on that. We have a lot of rain going on here right now, but not to the extent I think that we had before, where we were concerned about our creek and stuff flowing over. But it does make taking the puppies out, because they don't care. They want to run around out in the rain and play and get muddy and stuff. So we got to try to corral them in sometimes. And at like 3 or 4 in the morning, it's dark out, dark and rainy and cold, and they want to play. We're like, you know what? I know you guys are puppies, but there's another time for that. So the 2.2, hopefully we'll get going. And then I want to do, I also want to do on an LS. And maybe I'll do it on the portable 4.8. I want to do the pre-turbo methanol injection, water meth injection. I want to try that, just because I haven't. And a lot of the guys are swearing by it. I think I got grease on my finger. So one of the dogs has already got grease on him from climbing underneath stuff. He's a shop dog. But I do want to do the test of injecting it before the turbo, because a lot of guys are swearing by that, and they're like, "Hey, you've never tried that?" I'm like, "You're right. You're 100% right. I haven't tried that, and I haven't compared that to post intercooler or post turbo injection. And then I also want to inject it before an intercooler and see what's going on there, to see. I just don't see how we can't have puddling when the water meth, even when it's atomized, super atomized with the turbo, I can't see it falling out of suspension and puddling there. Heck, we see condensation there on ice water stuff, and we get water in there, but we'll see what happens. I want to test it because I want to know what the answer is, and obviously I want it to work. And I think, going in knowing what I know about all of this turbo testing, that if we do that and we inject it like the way that I did before, where we had a very short run of tubing between the turbo and the intake manifold, if we inject it pre-turbo and it atomizes the stuff better, that could help with distribution. But I still don't see how the liquid is going to evenly find its way into all the cylinders. But again, the testing will show that. And especially with, I think that the guys are probably running this, that are running, high horsepower deals, and they're running this water meth injection pre-turbo. They're probably running it with a good intake manifold, much better than the factory stuff. In terms of distribution, because the factory long runner manifolds and the internal design, not just the fact that they're a long runner, but the way that they're doing it, having the big tube like in the truck manifold, and the way that the air goes into the common plenum and then has to get to all of the runners. Air has no problem doing that, because honestly, the air is being drawn from the common plenum into all of these. But when you're asking water or some sort of liquid to go in through these and then find its way and dance around into all the cylinders evenly, it's a much harder deal. But again, I want to test it, and I want to see what's happening. We will probably try water meth injection on the 2.2 turbo and see what happens there. I'm curious to see on the 2.2 turbo what happens with fuel distribution. That's going to be kind of hard to test, because we can't really put O2 sensors in the factory 2.2 exhaust manifold. You can't really drill it and find out what each cylinder is doing. The only way to do that is to do some kind of dedicated header. And the header itself will more than likely affect airfield distribution or exhaust distribution. And so it's going to be hard to test and see what the effect has with a stock exhaust manifold. But lots of guys obviously have made good power from them. I just tend to think that I have another stock type exhaust manifold from Turbos Unleashed, or from one of those companies. This is an upgrade that I got on the motor that came in the Omni, and we will test that because it's bigger and repositions the turbo a little bit. So we'll see what happens with that. And it'll be interesting to test it versus the stock one with the same turbo, and then check back pressure and see if it's more restrictive. Like I said, it's going to be hard to test airfield distribution, though, to find out if there's a change there. And that's one thing I would be concerned about. along with the flow distribution in the intake manifold, which I think that and I'm sure that the Dodge guys had already adjusted the fueling in this on the stock intake manifold. It's not ideal, especially on the T1 non-intercooled deals. The later ones, the T2 stuff, the one piece and the two piece are probably much better for that. Let's see what you guys got going on. Doesn't every engine run between 26 and 36 degrees of lead? If you're way ahead of that, the books of Smoky Unic Advisor claim you're making the engine do things beyond the realm of mixing, but more for masking. Well, that's the range where we see a lot of engines running in. We see engines running way beyond that. A lot of big block Chevys will go into the 40s, especially the iron-headed big block Chevys. We have seen stuff go below 29. We just ask the motor what it wants. So we adjust the timing until it stops making power, and whatever number that is, that's what it is. Blank statements like that are not, because you're going to find stuff that's outside that range. And us wanting it to be there for convenience is a different thing. Will you be at March Madness? I will not. Richard, is a 7.6 DY NIC compression good to run 87? I'm sure you're asking if that's a dynamic compression, but dynamic compression doesn't determine the detonation threshold. It's not the only thing. What was the cost to build the Slant 6 that you had? The Slant 6 didn't cost me anything because somebody gave it to me. So I haven't, and I didn't really spend anything on it because I didn't, the only tests I think I ran on it, right, were intake manifolds and the turbo. What do you think of stock Ford 460 EFI, 1500 cc injectors and an S475 at 20 pounds will make? I don't know about the 20 pounds. That a stock 460 EFI motor is probably going to make, I'm thinking 300 or something, the way that we test it. So it's not going to be making a lot of power. Let's see. Yeah, so 245. Yeah, so that's going to be more like a Gen 5 big block. So it's going to be in the low 300s, let's say. So you're going to double it, 660, another 150. I don't know. I'm thinking it's going to be in the 750 range, probably. Rupert, you're just going to stare at your project for longer. Sometimes that helps, right? I'll be finishing my wire meth injection tomorrow. Cool. My 65 Mustang needs something fixed, changed, or upgraded every day, right? It's Type K thermocouple external to the manifold to the runners. We've used thermocouples to determine what the temperature change is, but that still doesn't tell you the amount of fuel or what the resulting air fuel is going to be, and it also doesn't tell you what the pressure is in each of the runners. I won't get my project done, but I'll work on it. Yeah, that's all that matters. It doesn't matter that you finish it. It matters that you start it or get something done. Let's see. William, I want to see someone with a brain test residual losses of a centrifugal blower as their major engine builders claiming it uses most horsepower at zero boost and restriction. I would agree with that. If you run what you want to do is run the supercharger at maximum speed for the impeller and maximum flow. And the maximum flow will come with no restriction. No restriction on the discharge side and no restriction on the inlet side. So you need to have a radius to entry and all that. That's where you're asking it to produce the most amount of work. And I have blower dyno tests on that. I don't know if Kenny Bell guys did any centrifugal superchargers, but it's going to work the same way. And I have horsepower comparisons against the turbo run at the same boost and the same air fuel and the same timing, and you can see what the losses are associated with driving a supercharger versus a turbo. It's quite a bit. It can be hundreds of horsepower. Go for broke. You're just here for the algorithm. That's it. There's nothing else here that benefits you. Got my truck running this weekend. Video on my profile. Leaking oil at the bottom, the rear engine cover. Oh, so is it a rear main seal? It's 15 below there, Dave. That is cold. That's too cold to work on stuff, certainly outside. I wouldn't be getting anything done. Any update or plans for your 396? I do want to run it, but I don't have a camshaft for it yet. What makes an engine rev up and down fast? Snappy throttle response? Is it the tune? It can be the tune. Well, that can limit it. Also, the rotating weight, the compression, really tiny flywheels, and clutches. Thermocouple temp data should give an idea of water meth is being evenly distributed. That's what we used on the Engine Masters deal. And we saw that it was not being evenly distributed, at least when we injected it post-turbo. I'm going to buy a 2009 Sierra 6.2. Has a 4-speed trans. Is it true those don't handle that motor? And what upgrades would you suggest? I don't know which 4-speed trans you have behind there. So I don't know the strength of the trans unless we know which one it is. For overall power, would it be better to spend the extra cash and get a 396 in comparison to a Smog 454 when leaving the stock heads? A bigger motor is definitely going to make more power. So 396s I don't see very much of in the wrecking yard, but there are a lot of 454s. And if you run the same things on the motor, you will not make anywhere near the same power on a motor that's, what is that, almost 60 cubic inches less. Richard, do you have any idea how much an unopened 727 trans will take? Does anybody have an idea? I'm not a transmission expert, and I've never run a 727 in anything, so I don't have an idea. My rear cover is leaking because I didn't align the cover properly with the oil pan. Okay. Took the Golf R, very cool, on a 2,200-mile road trip. Drove great, considering I don't do a shakedown run at a time. Yeah, because why would you? Loving the boost. Still need to get a boost gauge. That's a good idea. The 2009 Sierra was available with a 4-speed manual trans from the factory. If it's an automatic trans, then it's a 4L60 probably. If it was originally with a 4.8 or a 5.3, it could be a 4L80 with a bigger motor. Grab some forged CRW flat top pistons for the 2.2. Do the high compression E85 1,000 horsepower boosted run. We don't need high compression to make the 1,000 horsepower. And on this 2.2, it's not going to. It won't get there. In fact, 1,000 horsepower from a 2.2 or a 2.5 is going to be a pretty tall order, I think. Not that we shouldn't set that goal. So it's an automatic and not a stick. So when somebody says 4-speed, I think a manual trans. So if it's an automatic, it's a 4L60E or a 4L80E. Tractor has a Willys 226. Parts are hard to find. It would be worthwhile to swap in a Jeep engine. Yeah, a 4-liter Jeep or a 4.2 Jeep would be good because there's going to be lots of stuff available for that. If that's what you want to do, if you want to, or you could swap in a V8. Planning on building a new turbo manifold. We'll be going from 1.5 inch, 9 inch from the turbo. Are you doing a turbo exhaust manifold or turbo intake manifold? And then what size is the opening on your cylinder head? Going from a 9 inch runner to a 7 inch runner is the thing that's going to change it a lot. The change in 1.5 inch inside diameter, I'm assuming, to 1.75 will help flow. But with a turbo, usually the flow restriction becomes less of an issue. What would you do, Richard? My 72 Cutlass project car has a 350 rocket motor in it. Nice. That has started making noises from the bottom end. Would you rebuild it or just swap it for an LQ4 for better reliability? I like both of those cams. I think it's really cool that it has a rocket motor in it. And so you can always say that. And rebuilding that, as long as you didn't hurt something like permanently, if it has a rod knock and the rod's bad or you damage the crank or something, if you're going to change it out, maybe take it out and look at it and go, oh, that's going to be really expensive to fix that because now I need a new crank and new rods, maybe not new pistons, but if you're going to do all that and rebuild it, you're probably going to put oversized pistons in it anyway. So you're talking about a few things. If it hasn't hurt anything yet and you can just put new rings and bearings and oil pump and fix whatever the oil starvation problem was, that's an inexpensive way to do it. An LQ4 is going to be quite a bit better than if that's a stock 350 of ND vintage. A 6-liter is going to be quite a bit better and more powerful than that. So those are your choices. Have you ever used, let's see, water meth injection to spray fuel in front of an LSA blower to lower the inlet air temperature? I haven't done it on an LSA blower because I've never run an LSA blower on the engine dyno. I have run water meth in front of superchargers. We did it on the 3800, so you can take a look. That video's up. We ran it on the 3800 on the Eaton M90 that was in that. And it does lower the charge temperature. When the blow-off valve releases, it sounds like tires breaking loose. People love that blow-off valve noise. Fastest streetcar shootouts, claiming the fastest streetcars has been around forever. I wonder what the fastest car at Bonneville was that drove to and from without being on a trailer. I don't know what you mean by that. Are you saying that the fastest streetcar shootouts are saying that they have the fastest cars in the world that are street driven or something? I don't really understand it. Cosmic, imagine a Muncie 4-speed rock crusher behind a 6.2. That's what I was thinking he was talking about. That's why I wanted to know what 4-speed it was. I thought, wow, that's a but if a guy has that transmission sitting around and he wants to make it work, then it works. Blower shops offer drilling rotors hollow so they're lightweight. How much do you think that really affect the horsepower required to drive the blower versus solid rotors? I don't know. It's not going to change the flow rate of the blower, and you're not looking at a response rate change because that's going to be dictated by the acceleration rate of the motor and the vehicle. So I don't know. There may be a drop in parasitic loss from making the rotors lightweight. I'd be interested to see that. So Turbo Sentra, is this an intake manifold or is this an exhaust manifold that you've done? Richard, have you had any experience with a 3.6 Penstar? I have not. Oh, so you're talking about changing the header, right? Quite honestly, the header is not where I would spend money and time and effort on making it better. Because I don't think you're going to see much. At the power level that you're at and the exhaust manifold that you're describing, I don't think that that's a huge restriction. So we're down to 60% on people. So we have more no's coming in. That's pretty usual on the projects. Oh, sorry about that. I just turned it off. So everybody that was going to do the poll, I hope you all got in. That was a mistake on my part. That's the poll. Richard, is the distributor on the 2.2 locked or does it have some mechanical advance built into it? No, it's locked. There's no advance. In fact, that's one of the things that we were checking when we were looking at this. We're like, oh, it has all that timing on it. And we're like, the distributor's not locked. That's obvious because we've seen that happen before when we grab a billet MSD for a small block or something like that, and we try to run it. We're like, oh yeah, it's moving. That's not good. We have to lock that out. But that's the first thing we checked. And actually, the Dodge distributor has less slop than some of the others that we've tried. So it's actually in pretty good shape. And Scott, thank you for yesterday for getting on the call with me. That was cool. I did some trading this morning, and did pretty good on Tesla. There's a lot of volatility in Tesla. Richard, do you have a list of dyno proven Dodge 360 combos? I don't. Not anywhere near like I have small block Chevys or LSs and stuff. I've only run the Dodge a few different times. I haven't even put a camshaft in one of them, other than maybe the one I did with the guys from Engine Masters. Yeah, I haven't looked at that AI one, Scott. I'll have to take a look at it. Tesla's moving around a lot. It's having $5 and $6 swings, which is for a day trader can be a lot. $4L80E and Turbo 400 have the same gears. I know we even tried when we were running the Dodge 2.2 and we have the 24X crank sensor on it. We thought, well, maybe that sensor is used to seeing the dual, because it's a two-piece crank sensor on the 24X early LS stuff. Maybe we'd be better off using the 58X because that wheel is a single wheel and maybe it will recognize stuff better, but actually it didn't even want to run with the 58X wheel. So it was not happy. It likes the 24. Because it's a cathedral port 2.2. It's interesting also how much different these inline engines sound than typically when we're running V8s on them. It's a big difference. Can't wait to run boost, and the header and all that stuff is good. I'm kind of curious to see what happens when we run the long tube header, because Ben from the car farm gave me a long tube NA header, and I'm curious to see what's going to happen when we run that on the NA motor. So it'll be kind of cool. What worries you have when doing the big bang stuff, dyno room wise? Obviously you don't ever want to have a fire. You need to take precautions for stuff coming out of the motor. So you don't want oil to get everywhere and stuff. So what I do is buy those cheap Harbor Freight like shipping blankets, and we put them all around so that all you have to do is roll all the bad stuff up, and we can get rid of the parts. Airman, I don't know that I'm the right guy to hear that from. Is there a difference in quench between an NA and boosted engine? There isn't when we run stuff from the wrecking yard. We run boost on the same thing that we run on NA stuff. I don't build engines at a level where I would start juggling that. And I don't know that you necessarily would anyway. I'm much more concerned with the piston to head clearance and making sure that that's right. The one thing I can say on quench for boosted applications is the optimum way is to do what's called softening the chamber, so that then you can run, you reduce the its sensitivity to detonation, and that helps a lot, so that you can do what you're doing safer, and then you can run. A lot of times guys Brian was telling me that they have put more timing in it after they do that. So in that way, softening the chamber, but the actual quench distance for a lot of it might be the same. High versus low compression. Is there more of a question than that? So I just need cam at this point. I have a K20A2 style intake manifold. Okay. Yeah, for your Sentra, what I would do is I would get the intake manifold so it's running in the RPM range that you want to make power at. I would have the head ported so it flows well. I would put cams in it so that, again, it will make more power than stock cams do, which is, that's not hard to do. And also it will make power in the RPM range that you want to run at. And then you need to put enough turbo and have a good intercooler and good fuel and the right tune so that you can do what the turbo needs to do at the power level that you want to do it at. If you want to put a GT500 or a GT3582 that will make 500 horsepower and you want to get that to work, then you do the other things to make that work and get that power. That's what I would do. More NA power, more boosted power at a lower boost level. It's the triangle of power. Number 29. Please give a like. That's right. Please like, share, subscribe, ring the bell. Get those likes up. Head triangles. Yep. I'm stuck at 330 wheel horsepower. What boost level is that at? And how much timing is that? And what turbo size is that? Yeah, I have many questions. Because what do the Sentra motors make? The motor, yeah, what do they make NA? Let's see. So I don't know what year Sentra that is. TO4E, 18 pounds. Have you monitored back pressure at all to see what that is? Do you have a big open exhaust behind the turbo? MR20DE. Okay, 2007. Uh, 131 to 145 horsepower. So yeah, you should. Electronic throttle control, continually variable valve timing on the intake. Yeah, you should be able to get more power out of that. Oh, a 3-inch exhaust, that should be enough. T3 hot side on 3.8 liter V6, too small for 500 flywheel horsepower. No, there are we have we've run T3, T4 hybrids on 3 liter and 3.2 liter J series and the NSX motor, and made more than 500 flywheel horsepower. But it's not what I would do. We're going with the T4 now. A 10 bar map sensor. That's when you're doing the crazy compound stuff with diesels. That is pretty nuts. That's a lot of boost. It's like all the boost. Richard, do you know which of the Honda V6 heads? You mean which one of the factory heads flow the most? I don't know. If I had to choose, I would say it's the K series or the F. Yeah, there needs to be a Stan Weiss for import engines. that would be interesting. I doubt that none of the single cam stuff. The B series is not going to be in there. The J series won't I don't think flow. Not a stock one. It's not going to flow. I don't think anywhere near what a K does. There are lots of guys doing porting on those things that don't ever see flow benches, and I don't really understand that. I don't know how you. I guess just assume that it's better. Did you figure out the distributor issue on the 2.2 liter Dodge? Not yet. We think we know what it is, but we haven't tested it yet. Casey, yeah, we tried adjusting it. It's not a sensor. It's not a distance problem. Actually, guys on LSs are running the sensor distance much larger than that. They're running them out as far as 75 on some of the off-road stuff. I do like Saabs. They're pretty cool, especially a Saab Sonnet or an old Saab 900. Maybe a Saab 900 with a K series in it. Yeah, follow. I don't know if they have an oscilloscope there. I'd have to check and see. We'll have to see. We're going to try to cut it down. We'll have to see if they have a scope there. It would be interesting to try that to see if I'm going to have to ask Ish if he logged that. But the RPM is solid all the way through. Turbo Centric, is your head still stock? Rich, are you interested in getting more Gen 5 motors on the dyno? Brian Tooley's sending me an L33, an L83 that they did a bunch of testing on. He's actually sending that with the tune from James, and we're going to run a bunch of tests on it. So we have a ported and milled head. We have cams and stuff. So turbo sensor, the way that you make power is to run more boost, obviously. If the turbo won't do that, then you need a bigger turbo. Or make more NA power, and then you'll make the same power at less boost, and then you can run more boost if the turbo has capacity to do that. You can also look at cooling and back pressure and stuff. If you have a bad boost pressure to back pressure relationship, usually that tells you you need more turbo or a different one or a different hot side. Have you ever thought of doing over top full race engines? I don't know what you mean. You're not getting any sound? My mic is definitely on. I can see that. With short runner manifolds, NA, but size too small, cross-sectional area with the engine just flatline horsepower at the top of the curve. If so, would that mean needing a larger cross-sectional area or more cam? I don't know about the situation you're describing. Are you talking about a short runner intake manifold, first of all, or a short runner exhaust manifold? On a short runner intake manifold, I don't know how small you'd have to make the ports to do what you're talking about, but the reflected wave is still going to happen regardless of port diameter. So the reflected wave is still going to make the manifold efficient in a given RPM range. And then if we saw vacuum in the manifold because the runners were too small, I don't know where we'd have to measure that. Maybe down at the base where the cylinder head is. But one of those things is not going to cure the other thing. It's like the camshaft, the 4-pattern camshaft, trying to cure the problem that's inherent with a single plane intake manifold that has 4 longs and 4 shorts. It's not going to do that. You need to adjust both of those things. Doing full race engines, I have no interest in doing that. I'm not an engine builder. I don't build engines and then sell them. I don't have a shop or a company or anything like that. There are guys out there that do that professionally, and they're probably very good at it. Obviously, the guys that are winning, but I'm not at all interested in that. And that's not the market that my channel caters to. It caters to the average guy looking to make more power. It's making 152 wheel horsepower NA with the new intake manifold. So you should make 300 horsepower at 14 pounds of boost, to 14.7 pounds of boost. Since you're using an Ellis harness, could you use 4 LS coils? There's no reason for me really to do that. I've been trying to find some swap information on the Gen 5 motors, but I've been pretty unsuccessful. Does anyone here have a good resource to look into? What are you trying to do? The guys from Holly have swap like mechanical parts. So are you looking for more information than that? Two more minutes. 2 minutos más. Richard, when you get a Gen 5, can you find out if a Gen 4 head will bolt up? It will bolt on. You have to change the dowel position, but the bore spacing is the same, so that they will bolt on. And no, I'm not interested in having a Gen 4 head work on there. I'm not interested in doing that swap whatsoever, because it doesn't make any sense. It's way too involved. You have to have a completely different camshaft. You have to have a different intake manifold. You have to have a different header. All of the things have to be different, and that's just not worthwhile. Yeah, snow barrel. It's if you can make more power NA, if you can with the intake manifold heads and cam and then put boost in it, then obviously it's going to be better. Mike, a Gen 4 and a Gen 5 are definitely different. Are the adapters that he's talking about intake manifold adapters? Have you ever played with pre-turbo versus post-turbo nitrous injection? I don't think I've run nitrous pre-turbo before. That's what I was talking about doing the water meth injection pre-turbo because I haven't done that yet and I want to try it. The on nitrous, I personally wouldn't do it before the turbo. I would rather do it post turbo and get it as close to the throttle as you can because the reaction is going to be much better. And the gain that you get from nitrous is going to be from the oxygen molecules that you're supplying. And the quicker that you can do that, obviously, the more responsive it's going to be. And then you get a big gain in power, which then spools the turbo up faster. So if that's what you're looking for, I think that that's a better route. Now, the water meth injection, I think, is a different deal. So I'm hoping that we see gains from doing it. Yeah, turbo sensor, you might be at the limit of your turbo, and the back pressure will might give you a fairly good idea. Richard, will you be writing a book on Gen 5s? Probably not. I haven't done enough testing on them yet. Steadfast. The thing that I worry, and yours will be the last one before I get going. The thing that I'm worried about with you injecting it before the inlet air temp sensor or the map is that you're going to be skewing those the voltages for those things, and that's going to affect tune. So you might have to retune it if you're doing it that. If you do it afterwards, then I think it's not going to be affecting those sensors. So I would do it after. And on that note, it is time to go, but I will be back tonight. So if you haven't, please go take a look at the video that I posted already. And I'm working on another one today on all of the camshafts, the LS, Truck Norris cam, Chupacabra, the little hot rod torquer cam or something from, from Cam Motion, and then some Torquinator, I think, from Summit Racing. Just so you know, they all did very well, obviously. And on that note, I'll see you guys tonight. Near.